Okay, let's look through these problems here of finding an error approximation. So the key here is we know that the error is less than the next term here. So the next term is the fifth degree term there. So we know that the remainder is going to be equal to the fifth derivative of some number z over 5 factorial times x to the fifth. And it's not x minus c because this is centered at 0. So we're centering this at 0. All right. So we know that our function is cosine. We know that the point that we are evaluating this at is 0.3, and we're going to center it at 0 because 0.3 is close to 0 there. And we can find our derivatives. If we start with cosine and work through our derivatives, our fifth derivative is going to be negative sine x. Okay, so what this means is that the remainder is equal to some value of negative sine x of z, where z is somewhere between 0.3 and 0. So we know z, according to Taylor's theorem, is somewhere between 0 and 0.3. So there must be a z all over 5 factorial. So that's what that z is all about. 5 factorial is 120. Let's go ahead and work that out. 120 times x to the fifth. Okay, so the absolute value of that, which we know that this is less than, sine is always less than 1, and the absolute value makes it positive here. So this is less than 1/120th of x to the fifth. Now what is x? X is 0.3 to the fifth. And if we evaluate that, that's about 2.025 times 10 to the negative fifth. Okay, so that's our max error there. Okay, so the most that we could be off is off by 0.0002025. Whoops, I missed one more zero in there, huh? 0.0. Okay, 10 to the negative fifth. Okay, so there it is. So this should be pretty darn close. And if we evaluate this here, let's see what we get. So plugging this into the calculator, we get, let's see, 0.955338. That's the approximation. The actual value is 0.955336. So we say the exact error is, if we subtract those, 0.000002. All right, so we're off if we subtract those by that much. All right, so notice there's an extra 0 in there. Okay, so this, whoop, I lost my 2. Okay, so we know the error is at least as good as that. So that's the idea. That's how this Taylor approximation. So Taylor's theorem says that there must be a number that is the exact difference, and this is what we call the LaGrange error. LaGrange said that if we can find the maximum value on the interval between 0 and 0.3, so z lives between 0 and 0.3 here. If we can find the maximum value, well, we know the maximum value is going to be 1 at best. So we can say that it is going to be less than this. So this is an upper bound.